Hello, and welcome to your geometry lesson for today. Today we are finishing up chapter 5. So this is chapter 5, lesson 8, and we're going to be talking about coordinate proofs. As you can see from this diagram here, we're going to be talking about things that are on an XY coordinate plane. So a coordinate proof is a style of proof that uses coordinate geometry and algebra. They're very informal, and typically we write them as a paragraph proof. Okay, so we don't have to be super specific, but we still have to be specific. So we're going to write typically these as paragraph proofs, and they'll be written on a coordinate XY plane typically. So remember all of these formulas that we have been using, because sometimes we just use them in the middle of our proof for slope, midpoint, and distance. And another one that you might want to use sometimes instead of the distance formula is sometimes we use the Pythagorean theorem. And so remember, the Pythagorean theorem only works for a right triangle. And so we can say a squared plus b squared equals c squared. So I've used that a couple times, especially when we were finding lengths of vectors. But Pythagorean theorem and distance formula are basically the same thing. Okay, so the first step when you are writing a coordinate proof is to position your figure in a nice location. What I mean by nice location is when we're talking about an XY coordinate plane, we don't want to position something like this, so it's going through all four coordinates. We would rather have you write this as the origin and put this as the bottom side, so put that as the bottom side, and then up. So now that we are using the x-axis and now everything is in the first quadrant, so all of your numbers are positive. Okay, so you might want to stop this video and write these 4 bullet points down for strategies for positioning figures in your coordinate plane. So the first one is kind of what I demonstrated here, using the origin as a vertex and keeping the figure in quadrant 1. So centering it at the origin, using a side of the figure at the origin, and using one or both axes. So you can see I use the origin, I'm in quadrant 1, and I lined this up on the x-axis, which is better than how that blue triangle was. And even like using something like this, yes, it's still centered. Yes, we're still using an axis, but here your numbers are both positive and negative, or negative actually, both of them, because we're going left and down and only in the third quadrant. So you're better off putting things in quadrant 1. Okay, strategically place the figure in the coordinate plane and assign coordinates. So assign coordinates to each of the vertices. So we're going to make a right triangle, and your legs are going to be A and B. So you go ahead and give this a try, give a sketch following those rules and see what you come up with, and then come back and see what way or how I placed it. All right, right triangle. So if I'm going to do a right triangle, I want to use this vertex as my right angle. Okay, now they want us to assign everything, so I'm going to call this is going to be 0, 0. And they say that we're going to have lengths A and B. So I am just going to call this over A, 0. And this one's going to be not over anything, but it will be up B. Now, someone else could have done this exact same thing and made your triangle. You definitely want to make sure that these are not the same length, so that this length and this length are not the same, because they give us 2 different letters, A and B. So some of you might have called this B0, and you might have called this point 0A. They don't specify which way you have to do it, so either way is totally fine. Now I happen to draw mine up. You could definitely do it this way. That is totally fine. It doesn't matter as long as you make sure that this is a right angle in here. Now you can call this over A, up 0. But now this point here is going to be over A and up B. Now, does this use all of the strategies of putting the vertex at the origin? No. So the first two I drew were better, but those other two are definitely, the last one would definitely work. All right, moving on. So strategically place the coordinate and assign coordinates. So make sure you're doing assigning the coordinates. That's what sometimes kids forget to do on the test, to each vertex. The rectangle with length M and the width twice the length. Okay, go ahead and give this a try and see what you get, and then come back and see what I got. All right, I'm just going to make my rectangle here first. So assigning my vertices, so I'm at 0, 0. All right, so this over here is going to be M0. Now, it says the width is going to be twice that length. So this thing here is going to be over 0, but it's up 2M. And this point over here is going to be over M, 2M. Okay, now another way that you could have done this is you could have drawn it this so that your rectangle is this way. So if you did that way, this point over here is definitely the longest, so that has to be 2M0, and this would be 2M, M, and this would be not over anything, and M. Either way would be acceptable, but we're using the first quadrant, we're using the axes, and we're centering it at the origin. All right, so go ahead, stop this video, pause it, and then get this information down, and then we're going to go through how to write this proof. So remember, we're going to write this as a paragraph proof, and our object is to try to get those two triangles congruent. All right, so what is my path, or what am I going to do here? Well, they tell me that this is bisecting OG, so I'm going to be able to get this angle congruent to that angle. And then the rest part of my plan is I'm going to get GJ congruent to GJ. And then I need one more thing. So I'm probably going to get this GO congruent to this piece right here. So since we're on a coordinate plane, I know those vertices, so I can find the lengths. So in here, I'm going to start by saying by given, GJ bisects OGH, so that makes those two angles congruent. And then GJ is congruent to GJ by reflexive. Okay, now I'm going to use this coordinate plane. Since O is at 0, 0 and G is at 3, 5, what I'm doing here is kind of in my head, I'm making a right triangle here. And so the length of this is 5, and the length of this is 3. So I actually used the Pythagorean theorem here and said 3 squared plus 5 squared equals my OG squared. And I got it to be the square root of 34. Then I have to also get GH. Well, GH, I don't have a right triangle. Like if I go over here, well, I guess I do. I could have made a right triangle over here that way too, exactly the same, but I didn't. I just used the distance formula. So remember, it's the x's minus the x, so 3 minus 6 quantity squared, and then 5 minus 0. So remember, this is -3 squared. So -3 times -3 is a 9 plus 25. And so we're getting the square root of 34. So one I did Pythagorean theorem, one I did distance formula, but my answers come out to be the same. So now I have this side congruent to that side. So, whoa. So I have my two triangles congruent by side, angle, side. So my two triangles are congruent by side, angle, side. Okay, one last thing I think we're going to go over here is there's a PSAT test. I don't know if they're doing that too much at the high school, but this is a kind of a question that you could get on your ACTs or something like that. So we're just going to go through this since it is relevant to what we're talking about. Okay, so we have a point P is reflected across the x-axis to point Q. So instead of P to P prime, they're saying it goes from P to Q. Q is then reflected across to point R. Now they want to know what the area of triangle PQR is. All right, so let's start off P. P is -2, 1, 2, 3. So this is where P is. And we're going to reflect this across the x-axis. So remember, to reflect it across, it's got to be perpendicular. So 1, 2, 3, 1, 2, 3. This is where Q is going. Now Q is going to get reflected across x equals 1. So here is my x equals 1. So I have to reflect it across that. 1, 2, 3, 1, 2, 3. Okay, so this is where my R is going to be. So now they want to know what the area of this triangle is. So area of a triangle is 1/2 base times height. So 1/2, and this happens to be a right triangle, which makes it even easier. So what do we have? 1, 2, 3, 4, 5, 6. And our 1, 2, 3, 4, 5, 6. So 1/2 of 6 is 3. 3 times 6 is 18. Must be this letter D. All right, so we did a little bit of review and reflecting across and reviewed our triangles. All right, that brings us to our homework time. So you're going to have an online assignment on 5/8, and then there's a worksheet in your folder. So you need to go ahead in today's folder and do that Celebrate Proof worksheet, because we're getting ready for your test on Monday. So we're reviewing now, and then we're going to review a little bit on Monday, and then take your chapter test on Monday. All right, good luck on lesson 5-8. Remember those pertinent things about getting things lined up and using things in quadrant 1 at the origin and using X and Y axes. All right, good luck.